Hello everyone. Before starting today's topic, let's have a brief idea of what we have done till now. Till now we have discussed physical quantities. For example, length, mass, velocity, or time, speed, etc. And then we categorize these physical quantities into fundamental physical quantities and derived physical quantities. So these derived physical quantities were derived from these fundamental quantities. To measure these fundamental quantities, we defined units, and these units were called as fundamental units. And for these derived physical quantities, we had derived units. These units were derived from fundamental units. For example, meter square, it was derived from meter into meter. So today we will be discussing various systems of units. Systems of units. So in different parts of the world, different systems were developed to measure these fundamental quantities. So let's discuss three of them. First one, it was the CGS system, or it was as well called as French system. The second one we'll be discussing is FPS system. It is as well called as British system. Third, MKS, or it is as well called as metric system. So in various parts of the world, different systems were developed. Now, so for these three systems, they measured three fundamental quantities, that were the length, mass, and time. So mainly in mechanics we deal with these three fundamental quantities, and for these three fundamental quantities, these systems developed different units. For example, in CGS system, for length, it was the centimeter that was defined. Centimeter. For mass, it was gram. And for time, it was second. So in CGS system, centimeter, gram, and second were defined for measurement of length, mass, and time respectively. So centimeter C, gram G, second S. C, G, S. Centimeter, gram, second. Second is the FPS system. So for length, the unit defined was foot. For mass, the unit defined was pound. And for time, it was second. So in FPS system, foot, pound, and second were used to measure length, mass, and time respectively. So foot, pound, second, and we called it as FPS system or the British system. In MK system, length, for the measurement of length, the unit used to, which was defined, was meter. For mass, it was kilogram, kg, and for time it was second again, second. So meter, kilogram, second, MKS, or we called it as the metric system. So as the world got more connected, there arises a need for a new system which can be internationally adopted. So, and this led to the birth of a new system which is called as Systeme Internationale de Unitas. or we simply called it as SI system. So this system was internationally adopted. Now this system is nothing but modified and enlarged version of MKS system. So it was the enlarged and modified version of MKS system. So enlarged and modified how? In MKS system we had the 3 fundamental quantities. In SI system we have 7 fundamental quantities. So 4 more fundamental quantities were added along with these 3 fundamental quantities, and 2 complementary fundamental quantities. So length, it was as well as MKS system, length, mass, time. These were already there. Now 4 more were added. They are temperature, luminous intensity, electric current, and amount of substance. So these 7 are there in SI system. For length, the unit which was defined was meter. So for meter we use the meter. For measurement of the length we use meter as the unit. For mass it is kilogram. So these were defined. Kilogram. For time, second. For temperature it is Kelvin. For luminous intensity it is candela. For electric current, ampere. For amount of substance it's mole. And their respective symbols are as meter. For it is m, kilogram, kg, second, s, or we write is s. Kelvin, K, candela, C, D, ampere, capital A. For mole it is mole, ml. So these are the 7 fundamental quantities, and corresponding to these we have the fundamental units. Now we will be discussing 2 complementary fundamental quantities as well. So first is the angle, and for this the unit we have defined is radian and the symbol is RD. Second is the solid angle. So measuring this we have defined steradian, and it is written as the symbol STRD. So now these are the fundamental units. They are defined to measure these fundamental quantities. So as we know that materials can be as small as nucleus of an atom or as large as planet, star or galaxy. So for measurement of physical quantities related to these materials, we will require units of convenient size. So what we require is the units of convenient size. So for smaller measurements, we mainly require smaller units, or we prefer smaller units. For larger materials or the physical quantities related to them, we require for larger measurements, we require larger units. So for smaller measurements, smaller units are used. For larger measurements, larger units are used, and these are related to them these fundamental units. So for example, centimeter or millimeter, micrometer or milligram, millisecond, etc. They are used for measuring smaller measurements. And for larger measurements, larger units are used. They can be kilometer, astronomical unit, or light year, or gigahertz, etc. These are larger units, and these units can be metric units, or the non-metric units. So metric units means they are related to these fundamental units in terms of powers of 10, in terms of powers of 10. For example, 1 kilometer. 1 kilometer equal to 10 raised to power 3 meter. So 1 kilometer equal to 1000 meter. Here we have used prefix k, kilo, with meter, and we have converted this meter into bigger units of kilometer. That is, 1 kilometer is related to meter by this 1000. 1 kilometer equal to 1000 times the meter. Or for smaller units, for example, 1 centimeter, it is equal to 10 raised to power minus 2 meter. Or 1 centimeter can be defined as 1 by 100th of meter, or 1 centimeter is the 100th part of meter. So here they are related metrically in powers of 10. So these are the metric units. So for larger measurements, prefix can be used with these fundamental units, and they can be deca, hecto, kilo, mega, giga, etc. And for smaller units, prefix can be used as deci, centi, milli, micro, pico, etc. In mechanics, we deal with 3 fundamental quantities, which are length, mass, and time. So now we'll be discussing different units of length, mass, and time. So we'll start with units of length. So first we have the SI unit that we have defined. SI unit of length is meter. Now how this meter was defined? So first it was originally defined in 1889. That is, we took one platinum iridium rod and it was kept at 0 degrees Celsius at International Bureau of Weights and Measures. Now 2 marks were made over it, and this distance was called as 1 meter. So this was the definition given in 1889. Now this definition was changed later in 1960. So in 1960, how we defined meter? It was, we took Krypton 86 we took, and when its atoms or molecules, they made transition from higher energy levels, high energy level to low energy level. They emit electromagnetic radiations. Magnetic radiations. And these we call as emission spectrum. And in this emission spectrum we have taken one particular spectral line that is related with the orange red spectral line. So wavelength of this orange red spectral line was taken and it was multiplied with 1650763.73, and this distance was defined as 1 meter. So this number was multiplied with the wavelength of orange red spectral line, which was one line in the emission spectrum of the krypton 86. But in 1983 it was again changed, as we know that the speed of the light in empty space or vacuum, empty space or vacuum, the speed of light is apparently constant or unchanging. So since the speed of light is apparently unchanging, so this can be used as a basic for all measures of length. So now how it was defined? So CGPM, that is the General Conference of Weights and Measures, it defined meter by setting an exact value, fixed value of the speed of light. So they set an exact fixed value of the speed of light, that is 299,792,458 meter per second. So using this exact value we have defined meter. And how it was defined? So two 99792,458 meter. So light speed is, it covers this much distance in 1 second. So 1 meter distance it will cover in 1 by 299,792,458 part of the second. So the meter was redefined in terms of the speed of the light, that is 1 meter is the distance traveled by light in 1 by 299,792,458 part of the second. So this is how meter was defined. As of now we have defined meter. Now for example we have to measure small objects, length of the small object, for example this cap. So for this meter would be considered too large, so we will need smaller units. So smaller measurements, we will require smaller units, or we can say subunits of meter, DRE. So for example we have to measure this cap. A meter will be too large to measure its length, so we will require smaller units, that is subunit of meter. That is, we can define them, we can divide the meter into 100 equal parts and each part equal to 1 centimeter. So a smaller unit can be used to measure the length of this cap. So in subunits we will be discussing mainly first metric units. that is they are related in powers of 10. So smaller unit first, let us discuss centimeter. So 1 centimeter equal to 10 raised to power minus 2 meter. This is how centimeter is related with meter. So here we use the prefix centi. So 1 centimeter equal to 1 by 100 meter. So 1 centimeter is 100th part of meter. Second, we will be discussing millimeter. So 1 millimeter equal to 1 millimeter equal to 10 raised to power minus 3 meter. That is 1 by 1000 meter, 1 millimeter. For example, we have to measure this length. So centimeter will be a bigger unit for this length. So again centimeter we are divided into 10 equal parts. So 1 mm equal to 10 raised to power minus 1 centimeter, or 1/10 of centimeter, 10th part of centimeter. So 1 mm equal to 10 raised to power minus 1 centimeter equal to 10 raised to power minus 3 meter. This is how they are related in powers of 10. So meter is the bigger unit, centimeter subunit of meter, mm subunit of centimeter, subunit of meter. This is how they are related. Or for example, we have to measure more smaller length, maybe size of the nucleus or the wavelength of any spectrum. So for that we will go with more smaller units, that is for example micrometer. Or we call it as micron. So 1 micrometer equal to 10 raised to power minus 6 meter, that is 1 millionth part of meter. If more smaller we go, it can be nanometer. So 1 nanometer equal to 10 raised to power minus 9 meter. So these are the units which can be used to measure smaller lengths. Now we'll be considering, for example, we have to measure large lengths. That is, for example, distance between Sikar and Jaipur. So meter will be very small unit. Here we will go with kilometer. Prefix used is kilo. So kilometer. How it is related? 1 kilometer equal to 10 raised to power 3 meters. That is 1000 meters. So 1 kilometer equal to 1000 meters. So prefix we used kilo and it is 1000 times the meter. So these are the metric units.